Hello friends, a function is invertible if and only if it is 1 1 and onto. Let's try to understand this. So first of all, let's try to understand what does invertible function means. So let's have a function over here. Let's say that I have a some function f over here. You input some x value and this f does some operation on it and outputs you with a y. Now what is my question? My question is, can I get that value x back? Like, can you construct a function such that if I input a y, I get my x back? So the thought of constructing such a function calls for an inverse function of this function. So if I can have such a function g, you can have such a function, then we will call this function g of x as inverse of f. Or I will say that my function f of x is an invertible function. That's it. Now what is the hitch then? The hitch is only that can you have such a function? Let's see. I will give you an example to show you what should be the hitch here. So if I have defined my function from a to b, okay, so you already know, right? If I am defining my function a to b, my a is the domain of that function and b is the codomain of that function. These terms, okay. Now I am defining the rule of f, that f of x is x square. So now my a domain has points, 4 points. So you have, let's plot it here, -1, 0, 1 and 2. And your b has points 0, 1, 4 and 9. Now if you map to according to the rule which is given to you, what are you going to do? Your -1 is going to map to 1, 0 is going to map to 0, 1 is going to map again 1, 2 is going to map to 4. Perfect. Is this a function? Now, if you are aware of what is the property of a function, why it should be a function, you will say yes. But let's just quickly go through it. That every point in the domain is getting mapped. Every point in the domain is getting mapped and every point has a unique map, right? That 0 goes to just one element 0, -1 goes to just 1 0, 2 goes to just 1 4. Then you are going to say that yes, since every element has a unique map, it is a function. Yes, this is a function. Now let's try to answer the other question, that I want to get an inverse of that. That means I want a function something like this. That is that it should take elements of the range of f and give you the points of a. Now can this be a function? No. Why? Let's see. Now if I have, let's say, some function of g of x, I try to make, okay, then can you see that this point is not getting mapped? It has no pre-image. This point is not getting mapped. Okay. That deters g of x to be a function, because what did we say? That in every function, every element in the domain should have a map, right? Here it won't have a map if I define a function like this. Second, this is point number 1. Second point, that this one, can you see that this one has 2 pre-images, right? That means if I draw a map g of x like this, then my 1 will have 2 images, right? Which is also not allowed for a function. That means every element should have a unique image. So this is again another fact that this doesn't allows the inverse to exist, right? So now let's take another example to check again we understand. Okay, so let's say that I have another function h with the same rule. The only thing we did is we just reduced a point over here, okay, and then you have 0, 1, 4 and 9. Okay. Now according to the same rule, this goes to this, 1 goes to 1, 2 goes to 4 and 3 goes to 9. Very nice. This is a function, definitely. Now the question is the inverse also a function? Why not? Because of course 9 has a pre-image of 3. Okay, every element in the domain of G now is getting mapped and every one has a unique map. So even G is a function now. So Gx is a function. Gx is a function and we are going to denote g of x as f inverse of x. So now comfortably I can say that my g, whatever function is that, g is inverse of, so h, okay, so this function is h, I should write h inverse of x. So my g is what? A function from b to a, okay. And what property did it hold? It said that, what property did my function h hold? It said that every element in the codomain is getting mapped, right? That means you are saying that range of h is equal to b, right? Range of h and the codomain b are the same set, not subset, right? Unlike here, it was a subset, okay. Can you see that this element was not getting mapped? Here range of f was a subset of b. Here it is equal to b, right? And when it is so, your function h is called onto or surjective, okay. Your function h is called onto or surjective. Next, that nothing like this is happening, right? Two people here, can you see that? Here two are not going to one, many are not going to one. Everyone has to have their own images separately, okay. So the second thing is that your h of x is a 1 1 function. 1 1 function, or I can say is injective map. Your h is an injective function. 1 1 function or injective function. Everyone is having just 1 1 1 1 1, okay. No 2 will go, no many will go to a 1. So these two criteria fix it up. If any function follows that it is onto and it is 1 1, then I can say that my function is invertible, or there exists an inverse of that function. So as of now we are clear about this, isn't it? That my function is invertible if it is 1 1 and onto, or in short we say that it's a bijective, okay. Now I will give you a couple of examples to clarify this even more. Let's have this linear function. Now in this linear function, you know that if your domain is R and your codomain is also R, then I can represent this domain on the x-axis and the codomain in the y-axis, okay. And if I try to plot every point, every x comma y, okay, for an input x, if I am getting an output y, I can plot in a graph and get some graph, okay. In this case I have a linear graph. This is a linear graph. Now the question is, like, is my linear function 1 1? What should be my answer? Is my linear function 1 1? So you say, okay, well, what I just now learned is that for every y you have just one x. For every y value you just want to have just one x, right? Can you see? Every y value you want to have just one x. Here it was not allowed because for every y value you had two x's which were mapping to the same y, right? So here it was not invertible. Okay, so now how do I test that? This is something called horizontal line test. Horizontal line test. If you draw a horizontal line and it cuts the graph just once, that means for that value of x you have that value of y, that just one value of x. So here you see that you can draw any horizontal line, you can just, it will intersect the graph just once. So yes, your function is a 1 1 function. Is it onto? Then what should I see? That every point in the codomain, do I have a pre-image? Okay, so let's check. Every point in the codomain, let's randomly choose one point here. Does this have a pre-image? Oh yes, I can just check that it does have a pre-image, right? Oh wait, I want to take this point. Well, okay, so in this point in the codomain, it does have a pre-image. So every point whichever you want to choose in the codomain R real line, you have a pre-image. So yes, it is onto. Yep. Similar reasoning, I can change the graph here. So if I have again from R to R, okay, let's say my graph looks like this. Is it 1 1? Well, yes, my horizontal line says that, yeah, for every y you have a unique x. Then yes, it is 1 1. and this horizontal line I can draw throughout the range of f. Okay, now is it onto that? Okay, well, this is my codomain. Let's choose any point in the codomain. Does it have a pre-image? Yes. Wait, I want to choose this point. Okay, go ahead, choose this point. Does this point has a pre-image? Well, yes, yes, then it's even onto. So can you see both the functions are 1 1 as well as onto? Hence, what can I say about that function? That it is an invertible function, or the inverse of that function exists. Okay, and can you also check for both of these functions, this was a decreasing function and this was an increasing function. So for any function which is monotonic, that is either increasing or decreasing strictly, then your function will be a throughout its domain. Okay, function is increasing or decreasing throughout its domain, then your function will be a 1 1 function and onto function. Okay. Just 1 1, not onto. Okay, so onto says something more. Okay, now here let's have this function. Is this function 1 1? If I define this function from R to R, is it 1 1? Well, clearly no, because I can draw so many horizontal lines that cuts the graph more than once. So it's certainly not 1 1. Is it onto? Well, let's check. The codomain is R. If this is my codomain, I choose any point in the negative direction. Oh no, I don't have any pre-image of this point. So no, it is neither 1 1 nor onto. Okay. Okay. So well, can I do something about it? Okay, so let's see. Now if I have my function f, let's say I change my domain. Okay, I say from R to R. Is it 1 1? So as soon as you define your function from R plus to R, now what does it remain? Only this much, right? Because now your domain is only positive values. Okay, so just this much is your graph now. Forget about this other half. Okay, only this is the graph. Now if you draw any horizontal line, it is going to cut this graph just once. So yes, it makes it onto. It makes it 1 1. Does it also makes it onto? Let's check. This is my codomain. So again in the codomain, if I choose a negative number, it doesn't have a pre-image. So no, still I haven't made it onto. So again, next question, can I work through it? Answer is again yes. Let's have my codomain as R plus as well. So it is anyways 1 1 because still this half is there. And once you make the codomain to be R plus, that means only this real line is there, the positive part. And now if you take any point on this, it does have a pre-image, right? It does have a pre-image. So yes, it is onto. So what did we do? We played around the domain and codomain for even a function which was not 1 1 and onto, so that I can get a 1 1 and onto. Okay. So similarly, let's have this last one so that everything is totally clear to you. Let f again be R to R function, which looks like this. I can certainly see it is not 1 1 because if I draw any horizontal line, it can cross the graph so many times. So no, it is not 1 1. Is it onto? Well, if I take any point other than in this range, like let's say here or here, it doesn't have a pre-image. So no, it's neither onto. Well, again, what is the game? Let's play around with the domain. Okay. Now I can restrict the domain. Okay. So let's make it an increasing function. I want to restrict from here to here because I can clearly see it is increasing here. You may want to do from here to here, that's okay. Or from here to here, that's okay. I just want this chunk to be in my function. Okay. So if I want just this chunk to be in my function, I will restrict my domain from here to here. Okay. Now the graph I have drawn is my sine function. So the restriction I have made is from negative pi by 2 to pi by 2 to r. Does that makes it a 1 1? Yes. You can draw an horizontal line. Let's consider the already drawn line. It is cutting this blue one exactly once. Okay. So what? Any horizontal line is going to cut exactly once. So yes, it is 1 1. Is it onto 2? Well, with the same logic, if I take any point outside 1 and negative 1, okay, so No, you don't get a pre-image. Well, again what? Same question, can I play around codomain? Yes, in this case, yes. I'm going to play around my codomain and I'm going to say that the codomain as well is -1. Okay, what did you do? You have actually made the codomain equal to the range of that function. Okay, so now what? If I take any point in the codomain, it does have a pre-image, right? Any point in the codomain, it does have a pre-image. So yes, we have made it a 1, 1 and onto function, and now my inverse can exist. So hope I have made things a little clear. Hope this helped. See you. Bye bye.